Good afternoon, class. I'm so sorry that I could not be in class today, but we are still going to have a great day of learning. So last week, we reviewed various properties of circles, such as radius, diameter, and circumference. So now we're going to investigate what happens when we add lines, angles, and other geometric figures in and around the circles that we've been working with. So today, we're going to start our work with tangent lines. Tangent lines are very important in designing buildings, studying astronomy, and creating art. So you're going to see these type of features, these tangent lines on circles, outside of our math classroom, and you will see these in the real world. So if everyone could please open up Geogebra and click on the geometry section, we're going to pause the video for a moment until everything is set up and ready to go. Okay, now that everyone is ready to get working with GeoGebra and creating some tangent lines, I want to remind everyone, be sure to copy down the steps that we worked through together. You can take your notes on GeoGebra, or if you want to do it on a separate sheet of paper instead of typing, that is completely fine as well. But just so you know, I will be checking these when I return to class, so I need to see some form of notes in whatever format works best for you. One thing you do need to make sure you do on GeoGebra, though, is taking screenshots of your work. So when we're done going through the steps together as a class, and when you're done with your investigation, be sure to follow each step that tells you to take a screenshot, because you're going to submit those when you're entirely done. So now let us begin, since we are finally all set up, and we are going to just begin our discussion on tangent lines. So just a rough definition to begin with is that a tangent line is a line in the plane of a circle that intersects the circle at exactly one point. That's kind of a lot, so let's make sure you all write this down. So if you click on the ABC section and then click on text, you can write directly on your notes. For those of you who want to do what I'm doing and type your notes, this is how you will write this format. So a tangent to a circle is a line in the plane of the circle that intersects the circle at exactly one point. So I want to make that clear too. So it'll intersect at exactly one point. And once you've typed that out, hit OK. So this is a little bit of a formal definition. So I want you guys to pause the video for a moment, and I want you to discuss with in your groups if you can put this definition into a more comprehensible, easier definition for you. So take a moment, pause, and discuss. Okay, great. Now that we've sort of worked the definition in our own words, we will talk about those definitions tomorrow and what sort of this means to you when you hear about a tangent circle. Another element of the tangent line is the point of intersection, and that point is called the point of tangency. So to add to your notes, click ABC again, click on your GeoGebra page, and the point where a circle and a tangent line intersect is the point of tangency. So as we work through these next couple sections, you will hear me reference the point of tangency. So make sure you understand that that is what it is referring to. So another really important element of a tangent line is that it creates a perpendicular line with the radius at the point of tangency. So let's make sure we get that down as well. So if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Tangency. Okay, with your groups, I want you to discuss what it means to be perpendicular. We've talked about this in our class before. You've probably discussed this in your algebra courses. So I want you to, with your group, one, explain what the definition of perpendicular is, and two, I want you to think of a reference of when you've used a specific time when you've used the term perpendicular before. So if the substitute teacher could please pause the video as the class discusses in their groups. Okay, we'll review a couple things right now, but we'll go over the perpendicular because I'd love to hear what your specific examples are once I return. But just to make sure everyone is on the right track right now with the definition of perpendicular and how it's used, is one element of a perpendicular intersection is that it creates a right angle. So one example is if we were to graph two perpendicular lines, which you would have done in algebra, they would have opposite and reciprocal slope. So if you remember that opposite and reciprocal would mean that if the slope of one line is 2, then the slope of the other perpendicular line would be -1/2. So I want you to keep this in mind as you work through your definition. The importance of perpendicular, and that it is where the point of tangency and the radius intersect. So now that we've learned a little bit more about the meaning of tangent lines, we are going to learn one method of creating them. So if we could pause the video for a moment, make sure everyone has all of their notes taken down, then we'll move on to actually how to create these tangent lines. Okay, now that everyone is on the right track, I'm going to slide up the notes so that we have a little more room to work. Again, make sure you copy down the steps that we work through together. You will be creating more on your own later, but I want to see a screenshot of your work as we work through. Okay, so we're going to begin by making a circle. So you're going to click this circle with a point, the center, circle with center through point. So if we create a circle, the size of the circle at this point does not matter. One important thing to remember when we're working with GeoGebra is if we're going to move figures around, you want to click back on your mouse. That will allow you to move it in and out without messing up any of your created circles or lines. Great, so now that we have our circle, I want us to make sure we're labeling everything. That'll make it a lot easier for us as a class to refer to different points. So to show our labels, you're going to right click on a point and say show label. So I want you to do that for your first 2 points. Okay, now we are going to create a third point outside of our circle. So if we go here, circle, click on point, it can be anywhere outside. I'm going to put mine to the right, okay? So now we have our points A and B, and I want us to label our next point, which is C. So I want you to right click there and label it C. So we're all on the same page here. Next, we're going to draw a segment from A to C. So if you click on the line up there and click segment, we're going to go A to C. Now if we could pause the video for a moment and go around within your group, I want you to check and make sure you're all on the same page. You have a circle with a line coming from the center to a point C, labeled A, B, and C. So check each other in your groups, and then we'll come back together. Okay, good. Now that everyone's on the right track, we're going to keep moving. So now that we have this circle with a line, we are going to find the midpoint of AC. So in order to do that, we're going to come and click on the point icon and come down here to midpoint or center. So we're going to click on point A and we're going to click on point C, and we have found our center, and we are going to make sure we label this, and it is point D. Now that we've found our center, this line AC is going to become the diameter, excuse me, I had an extra point here, is going to become the diameter of a new circle. So if you can remember what we talked about last week, the diameter, it goes from one end of the circle through the radius across, and then from the end point to the center is a radius. So A to our point here, D, and C to our point D are each a radius. So now we're going to create another circle. Click here, and we're going to go circle with center through a point. So D is our center, and we're going to bring it out to our lines C and A, and you're going to click. And so you should have 2 circles, and D should be the center of your second circle. Okay, now it is time to add in our tangent lines. So in order to do that, I'm going to add points at these intersections here, and we're going to label these because, again, it is much easier for us to refer to specific points together. So we now have points E and we have points F. So our tangent line is going to come from point C to point E. So if we go down here and we click line, we're going to come from C to E for our first tangent line, and we're going to go from C to F for our second tangent line. So we have point E to C, so line EC is tangent to circle A, and line FC is tangent to circle A. So now that we've created them, there's a lot more that we can learn from these tangent lines. But you guys are going to investigate in your groups what the different elements of the circle and the tangent lines are, their relationships, other forms of developing tangent lines, through an investigation. So now that you guys know the basics of creating tangent lines, I want you to work with these a little bit more and manipulate them around. So your lovely substitute is going to pass out your investigative worksheet. You're going to work with your table group members to complete the assignment. And be sure to complete each question and submit the accompanying screenshots for your work. And we'll discuss all of this tomorrow and discuss all your different discoveries. So good luck, and I am excited to hear about what you think of this lesson tomorrow. Bye!